Welcome to another briefing. So in this briefing, I'm going to start out per usual as the satellite with the satellite image. We have a lot to talk about. Today we have this big warm spell, also a big round of offshore winds, northeast winds here in the Bay Area. I tend to focus on the Bay Area where I'm based, but I try to do a broad brush on the entire west coast of the United States. And what we're looking at here is we're seeing the back end of a trough here. This is an upper level trough at 18,000 feet. This is roughly what the jet stream is doing. It's basically separating the colder air to the north and the warmer air to the south. And something we tend to get on the back end of the jet is offshore wind, because you tend to get high pressure forming at the surface. Apologies, my cat is very vocal this morning. But you get this high pressure at the surface on the back end of these troughs here in North America. I could get into the science and physics of it, but I won't, because I don't want to make this video too long. But when this high pressure sets up over here and the winds are flowing clockwise around high pressure systems in the northern hemisphere, you get the wind, well, it goes out and around. So something roughly like this. This is what brings us a lot of even northeast wind. And you can see that acts to wipe out that marine layer. Because look at all this ocean fog. Kind of draw out where the ocean fog is out here. This is usually way in to the coastline here in California. But you notice it's getting wiped out. These dry northeast winds wipe out that marine layer, wipe out all that fog way offshore. We have quite a cold weather system moving across the Rockies right now. So most of this, if you look at the front end, it's precipitation, it's rain, it's snow in the mountains. It's a nice cold system for May. But on the back end, you have these warm, dry offshore winds. It's mostly because they're dry and then they're moving downhill. And as they downslope, they warm. And you can get warm, dry air all the way to the coast. Now let's take a look at the winds in the Bay Area. Look at this. North winds pretty much everywhere you look, even down to the lower elevations, down to the surface here. I mean, and you're looking at some pretty warm temperatures. This is 7 a.m. on Monday the May 18th here, 2026. I mean, looking at 67 at Ocean Beach, 7 in the morning. Sometimes, usually, most of the year, you don't get out of the low 60s during the day. So for it to be 67 at 7 in the morning, you know it's going to be a warm day at the coast. And I mean, look at this, 66 Christie Field, look at 66 Potrero Hill, 64 at SFO, and look at these gusts, gusting 29 SFO, gusting 24 at Oakland. The direction here you can see mostly out of the north. Pretty unidirectional flow across the Bay Area. You're looking at these north winds. Pretty impressive. Let's take a look at humidity for a sec. I'm going to take out the temperature. I'm going to put humidity. It's going to show in green. Look at these relative humidity values. In the 20s, 30s, even down by the water. I mean, I'm seeing a 42 here in Tiburon, but that's pretty low for being so close to the water. It's really dry air. You can tell these relative humidity values are quite low, and that checks out with all this north wind that we've been seeing. As I explained on the satellite image, on the back end of that trough digging through the Rockies, we have this high pressure system setting up over the Great Basin, basically just to the north of where we are. I'm going to go ahead and put a different chart here. Put the surface chart. So this shows you where the surface pressure systems are and such. And I mean, you can see, let me show here. See, there's this big high offshore, slightly out of frame, but you can see it right here. There's another little high in here. This might be a meso high. This might just be from nighttime cooling. And then you have another high over here. But basically, and then you have this low, I think this low is here for a different reason. We're not gonna get too much into that right now, but you can see these three high pressure systems over here. There's just generally higher pressure in this area, and you can see the front that's dragging past the Rockies right now. That's down here, and so here's the back side of that front. Here's the surface high pressure setting up, and counterclockwise flow around the high pressure. You're getting northeast wind. Okay, here's that really strong one offshore, and then these can kind of supplement it in a way, but we're just basically seeing, you look at the tilting of the isobars here, the equal pressure lines, and you have a tight gradient, so you're going to have strong wind, and you look at the tilting and the direction, this is going to yield a northeast wind, and that's exactly what we're seeing. So that verifies when you look at the surface chart. Now we'll take a look at the sounding. I know a lot of people don't really like this because it's very complex, but this is a very important tool in meteorology. This is basically all kinds of temperature, wind, humidity data that we get from the surface all the way to space, thanks to weather balloon launches twice a day in many areas across the country. This is out of Oakland from this morning at 5 a.m. Pacific, and you can see 67 degrees at 5 in the morning at Oakland Airport. Dew point 33. That relative humidity, if I'm not mistaken, was around 20 or 30%. But you see this large difference between the dew point and the temperature. That tells you it's really dry. When the dew point and the temperature are really close to each other, or almost touching, that's really high humidity. And then the dew point and the dew point and temperature are touching, that's 100% relative humidity. That's saturated air. This is far from being saturated. This is very dry air. As you see, temperature and dew point are quite far apart. And you see, actually, there's no inversion. One big thing I'm noticing here is no marine inversion in the lower levels. Usually this time of year, even up until last week, we had a pretty significant marine inversion each morning, and you had the temperature profile doing something like this because there was a strong inversion down here. It was cold marine air near the surface and warm air aloft. Now today it's warm all the way down to the surface here, and you just losing and you have that typical profile of temperature dropping with height as you go higher up, because there's no marine inversion this morning. So this is what we call a very well mixed layer. And these winds, of course, these northeast winds, pretty much throughout the lower troposphere, mid and lower troposphere, are helping, doing all that mixing, preventing that marine air from forming, mixing drier air down the mountains and hills, down to the surface. So that's why we have very warm, dry conditions this morning. And with a warm start, you're likely going to get a warm afternoon, and that's exactly what's being projected today per the National Blend of Models. You're looking at temperatures probably around 70s, maybe some upper 60s in the coldest oceans, coldest spots exposed to the ocean right along the coast. Bayside, you're looking at upper 70s, low 80s further inland. For today, I would say upper 80s, maybe even close to 90 in some spots. And then look at tomorrow, even hotter. Tomorrow you have, I would say, widespread 70s along the coast. Would not be surprised if we hit 80 even along some coastal spots, particularly if we have that continued offshore wind. Warm, dry, downsloping winds instead of a cold sea breeze, which would bring in the fog. You have this north wind that it's actually moving down these mountains, compressing and warming, and it's bringing very warm, dry conditions. And so this continues into tomorrow. Today and tomorrow, very warm days. Especially if you're near the water and you don't have air conditioning, because usually we don't need air conditioning in these areas that are really close to the water, that are exposed to the coast, because usually we're getting a really cold wind off of the ocean. Today, that's not the case. Tomorrow, that won't be the case. And so therefore you have these very warm temperatures. This might be some of the warmest readings of the year so far for areas near the water. In the inland, we have heated up a little bit already. We had a warm spell a week or two ago, but the coast looks pretty warm. And looking in the Wednesday, you start to see some cooling along the coast. This is a sign of an onshore wind returning. The winds will shift back to a westerly direction, bringing that cold ocean air a little further inland. So you're seeing that on Wednesday, and then definitely by Thursday, you're seeing a significant drop in temperatures along the coast. Probably back into the low 60s for the coast, mostly 70s Bayside. Inland could still be around 90 or higher for some spots. I mean, the National Blend of Models wants to bring Sacramento close to 100 degrees by Thursday. And that could happen far inland where you still won't have any marine influence and you have warming air aloft, and that mixes down to the surface and could be even hotter. But do expect some significant cooling on the coastline, I would say starting around Wednesday. I'll keep an eye on the guidance, and if anything changes, I'll do an update on it, of course. But that's all I have for today. Just be prepared for the heat, and I hope this was helpful. I hope you already got something out of it. Thank you for watching, and I'll see you next time.